This lesson, 3.1, is on page 163, and the name of this new chapter is this 3.1 anyway, is the meaning and properties of fractions. People mostly dread fractions. They don't want to deal with them because it's too much work. But it's one of those necessary things in math, something that you will always deal with. So let's go ahead and get to it. For one thing, a fraction definition is any number that can be put in the form, they call it A over B. Any number that can be put in the form of A over B and still equal itself. So, for example, if I have the number 12, I can write that 12 as 12 over 1. That means that it's a fraction, because I have two numbers here above and below a line that represent that number there. Therefore, it can be called a fraction. Okay, pretty basic, simple stuff there. Let's continue on though. If we have 3/4, 3 over 4, this number here is called the numerator. You can read my writing. And the number down here is called the denominator. Another name for it is a term. Both of these can be thought of as a term. So 3 is a term, 4 is a term, but 3 is specifically the numerator and 4 is specifically the denominator. Okay, a proper fraction, if you look in the middle of page 164, a proper fraction is a fraction where the number on the top is less than the number on the bottom. I mean, you can write an infinite number of possibilities where the number on the top is smaller than the number on the bottom, and that's called a proper fraction. An improper fraction is the exact opposite. It's where the number on the top is larger than the number on the bottom. 2, 3, 4, 6 over 3 is an improper fraction. The number on top is larger than the number on the bottom. One of the things that's also true when it comes to a fraction is if the number on the top is smaller than the number on the bottom, on the number line, that fraction is always less than 1. If the number on top is smaller than the number on the bottom, that number is always less than 1. If the number on the top is larger than the number on the bottom, then that number is always greater than 1. If that number on the top and that number on the bottom are the same, it equals 1. It does not matter what number it is. If the number on the top and the bottom are the same, it equals 1. So that kind of gives you some help on how big and how small these fractions are. The number on the top is less than the number on the bottom, it's less than 1. The number on the top is greater than the number on the bottom, it's greater than 1. If it's the same, it is 1. So, by saying it that way, the greater and the less makes it real easy to remember just by looking at it what size that number actually is. Equivalent fractions is something that kind of gets people a little confused, and an equivalent fraction is a fraction that may look different but is equal to the same, or the fraction that we're using. Alright, I'm getting a little confused here, so let me write one on here. 3/4. An equivalent fraction is one that equals 3/4 but may look different than 3/4. Like 6/8. 6/8 is the same thing as 3/4. It looks different, but they are equivalent fractions. And that brings us to a property when it comes to fractions. And that property is, if we have a fraction, we can multiply that top number by anything we want, but we also must multiply the bottom number by that same number. And when we multiply out, we will get an equivalent fraction. Those two fractions are the same. One just looks different than the other. But because we multiplied the top and bottom by the same number, they give us an equivalent fraction. And that's how, when we add and subtract fractions, we're able to do that, is because we can make these fractions into what we need by following this formula of multiplying the top and bottom by the same number, so that we can make it look different to make it work, so that we can add and subtract. We can even take this 3/4 and multiply it, top and bottom, by 4x if we want. Doesn't matter what we multiply it by, as long as it's the same number. So 3 times 4x is 12x. Remember, we can multiply when the terms are different. It would be addition, we couldn't do that. So that's 12x. 4 times 4x would be 16x. So this is equivalent to this, because we multiplied the top and bottom by the same term, or the same number. So that's how we go from one number to, or one fraction to another, and have an equivalent. Okay. You can also not only add or multiply the top and the bottom by the same number and get an equivalent fraction, you can also divide. So if I divide this by 2 and I divide this by 2, I get 12 divided by 2 is 6, 16 divided by 2 is 8. This fraction and this fraction are equivalent. If I divide this one by 2 and this one by 2 and get 3/4, this one and this one are equivalent, as is this one. Okay? So those are all three equivalent. 12/16, 6/8, and 3/4 are all equivalent fractions, because we divided the top and bottom by the same number. Alright, if we have a number over 1, that equals the number. So, not much to that. Any number over 1 is the number. Any number, again, like I said earlier, over itself is 1. Well, let's do some comparing of fractions in this section, and we'll be done then. Comparing of fractions gives you an opportunity to see which fraction is larger and which fraction is smaller. So what we're going to do is we're going to look at a fraction, or let's look at a fraction such as 5/8. And the instructions they give us in this particular example is, write this fraction with a denominator of 24. Well, how do we get this denominator to turn into a 24? We have to multiply it or divide it by something to make it a 24. Well, we can't divide it by anything and get a 24, but we know that if we multiply it by 3, we'll get 24. But we can't do that unless we also multiply the top by the same number. So 15/24 is equivalent to 5/8, and we follow the instructions about turning that into a 24. If we were to do the same thing with something like 3/4, and they were to ask me to make it so the denominator is 24, I would find out, what do I have to multiply 4 times to get 24? Well, it would be 6. And this, I have to also multiply that by 6. So I get 18/24. Therefore, these two numbers are equal to each other. And once I find that out, once I take several numbers together, and for instance, 5/8 I said was equal to 15/24, and 3/4 I said was equal to 18/24, I can compare these numbers and discover which one's larger and which one's smaller. When they have the same denominator, I can determine which one of these fractions is larger or smaller, because the smaller numerator will be the smaller number. But they both have to be over the same denominator in order to make that true. So that's the end of section 3.1. Watch the next video for examples.